So we continue with the basic image processing and analysis, now moving on to VOI-based masking. This can be useful for all modalities, creating nice images for presentation without things like the animal bed or high activity in organs that we're not interested in disturbing the image. The example we'll use will be for CT bed removal, and for this we'll continue using the view tool. Again, in the Bruker PCI database, we have a suitable example. If we sort by subject name and expand the subject tab, then we can select mouse 5, a low-dose PET-CT dataset, and we can select the whole body CT, add it to the selected for loading tab, and open. In this case, we see that, as a typical case, we have a mouse in the center of the field of view, and we can see the bed hardware surrounding the animal in any of the three orthogonal planes. At the moment, the MIP image is still turned on from the previous exercise. This is good. We see the skeleton clearly. This already tells us that 3D rendering or presentation of the skeleton could work without any special masking. But we can't really see a separation between the soft tissue of the animal and the bed hardware around it. And that's what we see in the image planes as well. The soft tissue, Hounsfield units, density compared to the plastic of the bed or the tubing for the anesthesia is all very similar. And so what we want to do is cut away all of that bed and tubing, leaving the animal nicer for presentation. So this is quite a convenient example for simple masking of the bed and the anesthesia tubing, because there is some separation between the animal and the inner bed of this cell. This could be because there was some foam padding put between the animal and the bed, but this gives us this nice separation, and then because of the cell structure, the anesthesia tubing is also separated from the animal to some degree. It can be even nicer when the reconstruction or when the bed itself was exactly parallel to the reconstructed field of view. In this case, we see that there's some sloping towards the head of the animal. And if we want to use a uniform VOI to do the masking very quickly, it's useful to straighten up the bed. And we can do this very easily using the reslicing controls. Up in the top right, in our image controls, the fourth main tab is for reslicing. You can see that it allows us to move, rotate, or scale the image. And once that tab is selected, we get a reslicing cursor in each of the three image planes. Grabbing the center box of that cursor by left click and hold gives us translation. So I can left click and hold here on the sagittal plane and drag the animal to the center of the field of view. I can then click outside that cursor to retriangulate, meaning that I can also see to center the animal in the axial or coronal slice as well. And then, based on this lower bed right below the animal, we can triangulate a location that allows us to see how parallel that bed is to our cursor line, and then with the smaller solid square on our reslicing handle, we have rotation controls. Again, I can left click and hold. I can then extend that handle, and I can rotate the animal on a plane by plane basis to bring that bed approximately parallel with the cursor line through my image. To start the masking process, we should proceed to the VOIs panel. So I use the workflow button in the lower right, and we move along to the VOIs tab. And here we should first understand the position of the animal in detail. So if we click at various locations along the body, we can see what kind of separation we have between the animal and the cell. In most cases, we will find that we have quite a clear separation from that bed component and from the tubing. Of course, we see that at the level of the head, the dimensions are smaller than in the abdomen, so we need to account for the whole animal when we make any masking. And as we can see from the MIP, one of the forelimbs is sticking out to the side, and if we explore the image carefully, we can see that that in fact almost touches or even does touch the outer cell. So if we don't want to lose that forelimb, we need to be careful with our VOI. So what we're going to do is use the 2D tools and then extend them to cover the 3D volume so that we can mask away the bed hardware. To make that a little easier, I will change the layout. So if I right click in the image display, we can then go to layout and select the Z direction, meaning that that coronal slice through the animal and the cell fills the image display. And now if we were to scroll with the mouse button or the touchpad, we can still explore the animal and work out what we need to include for rendering. I want to be particularly careful to keep this forelimb. So we know that the abdomen will be larger than the head, but we can clearly see where the bed is and the cell and this tubing. So now if I take the Vertex 2D paintbrush tool, I can then draw by left click and dragging, moving the touchpad or the mouse to draw a 2D ROI around the animal. And then what I can do is exclude the bed but include the animal and some space for the abdomen. In this case, if I left click, draw between the forelimb and the cell, then I can move up into the open volume of the cell, avoid the anesthesia, tubing, and move between the animal and the internal bed and rejoin my contour to create a full ROI on this slice. Then if we return to the orthogonal planes layout, we can see that in fact that is a single slice and we need to apply that to our full volume. Fortunately, that's straightforward. In the lower part of the VOI list where we have the contours listed, we have some additional tools, and if we expand the menu in the lower right of that, we can see an option to apply the ROI to all slices. So if you click on that, it's a very quick process. It extends throughout the image. We can return to neutral mode, and then we can explore the image as usual, and we can check how that near cylinder VOI covers our animal and check whether anything has been unduly cropped out. This looks reasonable. So what I should do now is take away all of the imaging hardware outside this VOI. And again, we have a direct function for this. On the right hand side of the screen, we have a VOI Tools tab. And within this tab, we have a data modification section where we have buttons for masking inside or outside a given VOI, and similar buttons for masking inside or outside interactive growing spheres, which is not what we want right now. So for this case where we already have a VOI that we drew ourselves, we can use mask outside the VOI. The tooltip that appears when you hover the cursor gives you some more information. If I click on that, we get a small dialog for masking, and we should choose what value we want to use outside the VOI. If I briefly cancel, we can check that by using the data inspector. We know it's CT, and we know that outside the animal should be air, therefore it should be minus 1000 Hounsfield units. And the data inspector shows us that that is effectively true with some precision. So then we can return to mask outside. We can set the value of minus 1000 HU. We don't want to do any additional masking inside, and we have the option to either replace our study or to create a new one. When you know what you're doing, you can replace, because we don't really need the image with the bed hardware anymore. But in this case, if we create a new study, then we can compare the result to the original. So when I confirm with yes, we have some quick processing, and then our new image appears in the image display. The MIP is updated, so now we see clear soft tissue of the animal without that background grey. If we switch between the two versions of the image that we have now, so we have the new VOI masked version and we have the original, then we can see that difference in the MIP very clearly. So in case we want to repeat this process, we can save this VOI, and by default it can be saved to the same database that we're loading the data from. So this can be the bed masking VOI, saved to the database. Then it can be deleted so we can see the image more clearly. And if we want to really compare this version of the image to the original, we can even proceed along the main workflow to the Compare tab, where by default we see 3 rows. On the top row are original data, which we can check using the small submenu below the image information. So we see checked the original data. On the second row we see our masked data. The third row at the moment is populated, but we only have 2 images. So in fact, using this menu at the bottom, we can turn off the third row and see that comparison of our 2 data sets more clearly. I can turn off all of the annotations so we can clearly see how we've removed all of that bed hardware quite effectively. If we want to save this image for 3D rendering, then we can use either the save icon on the right lateral taskbar, or it's also possible to go back to the View tab where we have a clear save menu on the right hand side. We can clearly select database, where, as we saw in an earlier exercise, we have the chance to edit info, where we could add to our series description. In fact, I need to select the other image first, VOI mask in the series description, save to database, where I could still change this series description. Instead of simply saying VOI mask, we could label that the bed has been removed. And then in the database we'll clearly see which image we processed, so that can be saved to the database. And then if we go to the DB load page for mouse 5 that we were working with, we now see that new series with the original CT whole body, and we have the CT whole body with the bed removed that we just saved.